To observe and identify metallic ions using flame tests to understand the relationship between the color and the electron configuration.
Bunsen burner, flint striker, glasses, goggles, chemicals, Q-tips, and water.
Drink water from a beaker. Use caution when working with flame. Wear your safety glasses at all times.
First, burn a plain Q-tip.
Record the color of the flame.
No. Put 6 drops of the solution onto a Q-tip. Burn the Q-tip, record the colors that the flame makes, and repeat for each solution.
The color emitted was a bright orange.
The color emitted was a bright yellowy orange.
The color emitted was a pinkish purple.
What emitted was a bright red.
The color emitted was a pinky red.
The color emitted was a pinky orange. The color emitted was a green-blue. The element with the most easily identifiable colors were lithium chloride, calcium chloride, and copper chloride.
Elements that were the least easily identified were sodium chloride, barium chloride, and potassium chloride, all of which were yellow or orange, which blended in with the flame. It was hard to identify.
The order of the energy of light emitted is strontium chloride, lithium chloride, calcium chloride, sodium chloride, barium chloride, copper chloride, and then potassium chloride.
The element that produced the color with the longest wavelength was strontium chloride, which was red.
The reason a flame test would be useful for detecting metal ions is because the flame reacts with the metal ions in a certain way that gives off a certain color, so you know what element is in that metal.
Our first possible source of error is not being able to control how much liquid is on the Q-tips. Though we could control how many drops were put on the Q-tips, we could not control how much liquid was coming out of each bottle individually. Our second possible source of error is that our glasses didn't work right. When I looked at other people's video presentations, I saw that they had a clear spectrum of colors when they looked through the glasses, but when we looked through our glasses, we didn't necessarily see a perfect spectrum of colors. Our third possible source of error is not having enough time to see the flame burn with the Q-tip. A lot of times we waited 30 seconds to wait to see how the flame burned with the Q-tip, but I think we could have waited longer to see the flame really erupt. In conclusion, We found that the chemicals with the least amount of electrons have the least bright colors, and the chemicals with the most amount of electrons have the brightest colors.